So we're going to find the surface area and the volume of the figure below. And what we want to do is, if you don't have the equation, make sure that you match it, find it, and match up the shape with the right equation. But they give it to you here, and we're going to identify the numbers and put them into the right letters. So pi is 3.14, so we're going to find the surface area first. They give us the radius, which is 20. Remember, the radius is halfway across the center of the circle. So we'll put that in for the r's. And remember that the L is the slant height, which is actually this green line that I drew here. Unfortunately, we don't have that. So we're actually going to have to use the Pythagorean theorem to figure that out. So we should see on here, I'm going to sketch out the rest of this, a triangle. So we're going to have to use the Pythagorean theorem to figure out the missing side. So a squared plus b squared equals c squared. We'll call this green line the hypotenuse, the x. And the a and b are the legs, and they're going to be interchangeable. So we'll say 20 and 21. 20 squared is 20 times 20, that's 400. 21 squared is 21 times 21, and that's 441. We add those together and get 841, and the opposite or the inverse of square a number is the square root. So when we take the square root of both sides, we're going to get 29. So that's our x, or that's going to be our slant height. So we can put that number here for our equation. So 3.14 times 20 times 29 is 1821.2. .14 times 20 squared, or 3.14 times 400, because 20 squared is 20 times 20, gives us 1256. And when we add these together, we're going to get a total of 3077.2, and now I will put the centimeter squared. Many teachers or books will put the centimeter squared throughout the whole problem. I just like to add it at the very end. The volume equation is 1/3 pi r squared, so we'll do the 1/3. I'm just going to rewrite it here. And often it's easier to find the volume than it is surface area. So we'll put in our numbers. Pi is 3.14. The radius of this equation is 20, and the height of the prism, it's not 29 because that's the slant height. The height was that dotted line up here, which is 21. If you're having trouble putting the 1/3 in your calculator, remember it's just 1 divided by 3. So 1 divided by 3 times 3.14 times 20 times 21. Is 439.6, and I think I hit the wrong button there to pause it while I put it in my own calculator, centimeters to the 3rd power. So if you need more time, go ahead and pause it. So identify the best name for this net. It doesn't really show it really clearly. It should show that all these sides here are the same. We'll assume that they are. So this would be a square pyramid. And then we're going to find the total area. And I'm not going to use the formula to find the surface area of this pyramid. I could, but this time I'm just going to look at it and just analyze it and calculate the pieces. We have 1 square plus 4 triangles, so 4 times the area of 1 triangle. Well, the area of this triangle here, or square in the middle, will be 10 times 10. So that's going to be 100, and I'm going to add the units at the very, very end. And the triangle, well, off to the side, let's remember that the area of a triangle is 1/2 base times height. And all the way across here, the base is going to be the orange one, that's 10. So 1/2 times 10. And the height of the triangle is 8. So 1/2 times 10 times 8 is 40.
So I can put the 4 in here, or 40 in here. So 40 times 4 is going to be 160. And when we add them up, we're going to get 260 feet squared for the total area. And you would get the same if you used the formula. So if you need more time, go ahead and pause it. So we're going to find the surface area and the volume of this rectangular prism. Let's start with the volume, because that's pretty much the easiest thing to ever find, is the volume of a box. So 6 times 4 times 14, you got length times width times height. So 6 times 4 times 14 gives us 336, and this will be to the third power. Now we're going to find the surface area, and I'm going to use the formula. Note that if you didn't like the formula, you could find the area of each side. There's 6 sides of this, and then add it up, and that would be totally fine as well. You do have options, but I'm going to use the formula. And we're going to assume here that the base is what it's sitting on. So the area, I'm going to do the big B first. Just the area of the base is going to be 6 times 4, which is 24. So I'm going to put that into our formula, plus 2 times 24. The height of this prism is 14. And then the P is going to be the perimeter of the base. This is where I want to add up the sides along the edge. So this would be 6 plus 4 plus 6 plus 4, which is 20. And once we have these numbers, we just put them in there and solve. So 20 times 14 is 280. 2 times 24 is 48. And when we add them up, we're going to get 328, and we're going to say that is inches squared. If you need more time, go ahead and pause it before we go on to the next slide. On this one, we got a whole bunch of different things to find. We're going to find the faces first, and the faces are like how many flat sides it has. So we got one triangle. There's 4 sides to the triangle, or 4 triangles in here. And there's 2 of them, the right and the front. We also have the left side and back, and then the right back. So we have a total of 4 plus the one on the bottom, so this will be 5 faces. I'm going to do the vertices next. These are the corner points. So there's 1, 2, 3, 4, and 5. The square pyramid. And the edges are the number of sides that connect the vertices. So let me get a straight line. Here's 1 in green, 2, 3, 4 so far. And I'll highlight some here in blue. So 5, 6, 7, and 8. So there's going to be 8 edges on this. And the volume, thankfully for this one, is going to be pretty easy to find. 1/3, or 1 divided by 3, times B. The B is the area of the base. It's a square, so this is going to be 60 times 60. And if my mental math is right, and I hope it is, that's going to be 3,600. And thankfully they give us the height. There's no tricks involved. That's 48. That's the line that goes from the middle of the base to the very top of the vertex of the pyramid. And one thing I do want to point out is don't use 0.33 for 1/3. It's 1 divided by 3. And if you use 0.33, you're going to have a rounding issue already, because your answer is not going to be exact. And assuming that I put this correctly into the calculator, 1/3 times 3,600 times 48 is 57,600. And that's going to be meters to the third power. If you need more time, go ahead and pause it. And for this cylinder, we're going to find the lateral area, which is just the stuff like the soup label on a can. And then we're going to find the volume of it. Typically, volume's easier to find, typically. In this one, it's actually going to be pretty much the same in terms of difficulty. So we're going to have 2 pi RH. So we want to identify each apart, and we're going to use 3.14 for pi. The radius is halfway across the center of the circle. Okay, we have that, which is 5. And then we have the height, which is the height of the cylinder. That's 9. And when we put that into the calculator, I came up with 282.6, and that'll be centimeters squared. And then the volume will be pi r squared h, or 3.14 times 5 squared times 9. And remember that 5 squared is just 5 times 5, which is 25. So we also can do 3.14 times 25 times 9. And when we put that in the calculator, I got 706.5. And this will be centimeters to the third power. So if you need more time, go ahead and pause it. So a cake has 3 layers that are all cubes. That means all the side lengths are the same for each of the cube. The side length of the layer on top is 3 inches shorter than the previous layers. The height of the bottom layer is 16 inches, as shown in the picture. So what is the total volume? So we have 3 cubes here that we need to find the volume of. And this question is probably a little bit easier than it may first seem. So for the very big cube of the cake, it's going to be 16 times 16 times 16, or 16 to the third power, which is 4096. We're going to add all these together. The next size is 3 inches shorter, so that means it's going to be 3 less, so 16 minus 3 is 13. And 13 to the third power is 2197. And the last piece of the cube here, the smallest top piece, is going to be 3 inches less than the 13, which is 10. And 10 to the third is 1000. So now we just add these numbers up, and we're going to come up with 7287 inches to the third. So that's how much cake there is. So if you need more time, go ahead and pause it. So we measure the circumference of a red spherical ball, and it's 314 centimeters. We want to paint the top half of the ball green. How much paint do we need? Well, we identify that, or we need to find that the surface area of a sphere is 4 pi r squared. How much do we need to paint? Well, recognize we're only doing the top half of this as green. So we're only going to do half of this. So right now we can already change it to 1/2 times pi r squared. And for some reason I missed the 4 in there, so let's go back and put that in there. And just to simplify this, 1/2 times 4 is 2. So our equation that we're going to use is 2 pi r squared. Well, pi is 3.14. That's what we're going to use because it tells us to. And we don't know what the radius is, though, so we're going to have to do a little bit of side work here to figure out what the radius is going to be. And they give us the clue that the circumference is 314. And we should know that the circumference is equal to 2 pi r, or in our case, 3.14 will go in for the C, and the pi we're going to use is, again, 3.14. So we needed to solve this equation for r, and once we have that blue equation solved for r, we can put it into the green equation to the right. So 2 times 3.14 is 6.28. So we divide both sides by 6.28. And that's going to give us that the radius is 50. So now I can put that value into the equation on the right in the green. So it's going to become 2 times 3.14 times 50 squared. And when I use the calculator, I got 15,700. And this will be centimeters squared since we're looking at area. If you have any kind of questions, please ask your math teacher.